is that covalent naming is between two nonmetals. Between two nonmetals. That's really important. So as we get to our naming all of our compounds, you need to be able to identify right off the bat, is a compound an ionic compound or a covalent compound. So the way you tell that is between an ionic compound is a metal and a nonmetal, and a covalent compound is two nonmetals, which means they're both found on what side of the periodic table?
That side.
Two nonmetals are both from the right side. Okay, or you can think about it as two anions. So if we're combining two anions, does that mean we can ever have a neutral charge? No. So the big thing about covalent compounds is that they do not need to be neutral. Okay, they do not need to be a neutral charge, and they won't even have a charge, okay, because they're both two anions that are bonding together. And so the difference between ionic and covalent bonding, which we'll talk about a lot more in future chapters, is that in covalent compounds, they share electrons. So they're not trading to one another, which is where those charges come from. They're sharing electrons. So in covalent compounds, you won't see a charge. There's no need for it to be neutral. Nothing happens there. Okay, so let's talk about how we put these two together and how we start to name them. Okay, so in a covalent compound, when we're putting them together, okay, I'll go through kind of basically 4 rules here. Okay, rule number 1 is that the element furthest left on the periodic table goes first. So we follow that same rule with ionic naming, right? The metal always comes first, then the nonmetal. So we follow that same rule when we deal with ionic naming. If there's two compounds that are in the same row, or the same column, it'll work usually like 99% of the time bottom to top. Okay, so the bottom one will come first, then the top one. That doesn't happen all that often, but it has to deal with electronegativity and all that kind of stuff. So usually it will work bottom to top if they are in the same column. Okay, so otherwise left to right and then bottom to top. Okay, in terms of which one comes first. Okay. Second rule. Now this deals with the naming. This goes with how we put together compounds. Next is how we name them. Okay. So when we start naming these covalent compounds, the first element my stylus is not very good. First element only gets a prefix if there is more than one. Okay, and I'm going to explain that rule a little bit further, but I need you to, we're going to copy down the table of covalent prefixes. Okay, so give me just a second here. Okay, so on page 67, there is a table of prefixes that you need to have down. So I put up here just a few examples of covalent compounds. The first two are really common for us. CO2 is called what? Carbon dioxide. Okay, do we see where that comes from? There's one carbon, two oxygens. Okay, one carbon, two oxygens. says the first element only gets a prefix if there's more than one. So you don't see us saying monocarbon dioxide, right? The first element gets a prefix only if there is more than one. Okay, so in the second one, what's this one called? CO is called carbon monoxide. Right? Now the second element gets a prefix no matter what. Okay? The second element gets a prefix no matter what. What's something else you notice about the second element? What's it end in? IDE. Name it just like a regular anion. Okay? So first element gets to keep its regular name. Second element ends in IDE like it's an anion because it is. Okay? If we looked at this last one, C2O2, anyone guesses on what this would be called? Dicarbon dioxide. Good. Okay, dicarbon dioxide. First element gets a prefix because there is more than one. It still gets to keep its regular ending. Second element always ends in IDE, so it goes prefix, then the root of the element, then the IDE. Okay, so that's kind of our next rule here. Okay, so rule number 3 is that it says second element in the bond is basically prefix, then the root of the element, and then IDE. Okay, so if I had something that was O3, what would that be called? Okay, if there was some other bond before that, whatever. But if this was my last element, what would I call it? Trioxide. Right,
Do you ever have any more than 10?
No, we won't deal with any more than 10. Okay, trioxide. So that would be our second one. I don't know why I put an E here. Sorry. Prefix, then the root, then IDE. So that's our kind of our third rule. The second element gets a prefix always. Always, always, always. The only situations in which we apply prefixes are for covalent compounds. You need to understand now when we switch back to ionic compounds, no prefixes. So when you see a prefix or when you use a prefix, it's only for covalent compounds, which is 2 non-metals. Okay? Yeah? Oh, root, like the root of the element. So ox for oxygen, or phos, for phosphorus, sulf, or whatever. So it's just the main part of the element. And you'll see those on your periodic table of ions. It's like this one says phosphide, or like phosphorus is weird. It's not phosphoride. I don't know why. Don't ask me. But some of them are different. Like sulfide is not sulfuride, right? So just pay attention to what those are on your periodic table of ions. The last rule is kind of just a pronunciation rule, and so you drop the O or A when the element begins with a vowel. So the example of that is that we don't say monoxide, right? We say monoxide. We combine those things. So it's just really a pronunciation rule. If we had O4, what would we call it? Tetroxide, not tetraoxide. Okay, so you drop the O or the A from the prefix if there is an element that begins with a vowel. Okay, and it's just kind of a pronunciation to avoid kind of awkward pronunciations. Okay, so covalent naming is significantly easier than ionic naming. You are literally just reading what you're given in front of you. Okay, you're adding the prefixes. That's it. Okay, you ready to try a couple? Okay, let's see here. You're going to give me the full name. So how many of you said this was sulfite? Anybody say sulfite? You shouldn't have. Okay, I hope you didn't. Why is this different than sulfite?
Negative.
What? Yeah, Nicole. Yeah, sulfite has a -3 charge, so we have to take that into consideration. So good. This is called Brogan. What do you think?
Sulfite trioxide.
Almost. Sulfur gets to keep its regular name. Sulfur trioxide. Okay, how many of you had that? Good. Sulfur trioxide. That's it. First one gets to keep its name. Second one goes prefix, root, IDE. Okay. How about this one? Okay, Jesse, what do you think? Phosphorus. We need to make sure we keep it at phosphorus. Phosphorus, and then what was your prefix? Pentachloride. So on your periodic table of ions, remember it only shows you the IDE version of all of these. So you need to understand that you need to still use phosphorus for its original, or for the first element. Phosphorus pentachloride, okay? So make sure we keep that regular name for our first element. I that goes with our second one. Is that what we had? Phosphorus pentachloride? Okay. What if I give you the formula now and you give me... I'm sorry, I give you the name, you give me the formula. Oh my goodness, I can't spell today. Yeah. N2, then what? I3. N2, I3. Okay? Nope, we don't need our charges to balance. We don't have to worry about any of that. This one should always be the one that comes left on the periodic table, right? It's got to come first on the periodic table. This one comes second. That means it's further to the right. But that's it with naming covalent compounds. The problem you will run into is that you will flip-flop ionics and covalents, right? You'll start using prefixes on ionic compounds, and you won't use, you'll just make them, you need to make sure that they are totally separate, right? Ionic compounds are neutral charge. You have to crisscross. You have to look at charges. Covalent compounds, we don't care about the charge necessarily. We're just naming exactly what's in front of us. Okay, so you need to make sure that you can identify the two. All right, so now I'm going to put up on here a mixture, okay, of ionic and covalent compounds. You're going to name them based on their individual rules, okay? Let's see here.
How many?
I don't know, as many as I decide. So I want the full name for each of those four. I3. Lauren, what'd you have? Phosphorus tri what? Triiodide. Triiodide. Got an N and an IDE. Is that what we had? Phosphorus triiodide. Okay. Na2CO2. Aiden, what'd you have?
Sodium carbon dioxide.
Mm-hmm. Anyone else have anything else different? Yeah, Nick, what'd you have? Sodium carbonate. This is perfect. Okay, sodium, is it a metal or a non-metal? It is a metal. It comes from the left side of the periodic table, which means you have to use your ionic rules to name it, right? I told you we'll start using prefixes when we shouldn't. Sodium is a metal. So in order to get these to form a compound, right, sodium is +1, carbonate is CO2 -2. So we crisscross those charges and we get Na2CO2. Okay, Cr3PO4 2. If we reverse the charges, we see, yes, phosphate is usually PO4 -3, which means Cr would have been +2. Okay, that's where we got that +2 Roman numeral from. Okay, last one here. Krista, what'd you have? Tricarbon oxide. Okay, anyone have anything a little different? You're really close. Tricarbon. Johnny, what'd you have?
Tricarbon monoxide.
Yeah, good. Tricarbon monoxide. So the second one has to have a prefix no matter what. So we should have had tricarbon monoxide. Tricarbon monoxide. Okay. Little trickier now that we have both types, right? You got to make sure you're identifying, is it ionic or is it covalent? That's the first question you answer. So if you need to write a little I or a C by those compounds to help you identify, do that, right? And then if you need to solve all of them at one time, then go back and do all of the others. That's fine. But you need to figure out how you can quickly identify which is which and then be able to name them correctly. Okay? Let's do a few more going from name to compound, and then I'll kind of set you loose here. So let's see. Okay, are we ready or we need another minute? All right, Jake, what'd you have on the first one? N3F4, agreed? What does di tell us? 2. Did you say 2 and I just misheard you or no? Okay, that's all right. N2F4. Okay. No, we don't reduce it. Covalent compounds, we do not reduce. Sorry, that was a good question. We do not reduce them. So covalent compounds are left exactly as their prefixes say. Okay, very good question there. Next one. Jesse, what'd you have for nickel 3 nitrate? NiNO? Okay. Not quite. We'll try again. Katie, what'd you have for nickel nitrate? Nickel 3 nitrate. Okay. Nitrate was a polyatomic ion that we needed to know. So nickel, if we said nickel was a +3, and nitrate is NO3 -1, right? We drop the charges. We crisscross these down, which means Ni. Since we need more than one polyatomic ion, we use parentheses. and we say 3. Does that make sense? Okay, yeah, Lauren?
So the ones that are like the Roman numeral ones,
Mm-hmm.
that doesn't mean that they have like a third like.
So this was our final for nickel nitrate. Sulfur dichloride. Eric, what'd you have?
K2S.
K2S. Sulfur dichloride. Oh, sorry. You did potassium sulfide. So potassium sulfide, K2S. That is correct. Yes, for potassium sulfide. Okay, I was like, what? Okay, so how about for sulfur dichloride? Cesar, why don't you tell me what you had? SCl2. Perfect. Okay, there we go. So this was K2S. That was perfect because potassium is +1, sulfide is -2. A lot of you will try to add SO3, SO4 for sulfide. Right? Remember when we see an IDE ending, it's the element only. 8 and ite are our polyatomic ions. Okay? How are we feeling? Pretty good? Okay, so our homework today.